Okay, now for part two about naming ionic compounds. So now we're at the simple binary ionic compounds. We're naming these compounds, not just the ions anymore. So an ionic compound happens when you have a cation and an anion, and they combine together to make a substance. So we always have a metal and a non-metal, essentially. And those binary ionic compounds have just two elements in them. That's what binary means. There's two, right? So when we're thinking about this, we're thinking about the simplest form of ionic compound, and that's enough for right now. There are more complex forms of ionic compounds that we're not going to worry about. We're not going to worry about polyatomic ions. We're not going to worry about transition metals. Those are things that are more complex, and if you are interested in those, you can look those up. But right now, I just need you to be able to know simple metal, non-metal ionic compounds. All right. So here's example number one. We have a salt containing sodium ion and chloride. And it's a 1-to-1 ratio because we have a sodium ion, which is +1, a chloride ion, which is -1. So we add those up and they come to 0. So therefore the formula for the salt is NaCl. Remember, that's like Na1Cl1, but we're not putting in subscripts when there's just one. All right. Another example is when we have a calcium ion and chloride. And it can't be 1-to-1 because calcium ions have a +2 charge and a chloride ion has a -1 charge. So those don't even out. Ionic compounds are collectively a neutral substance. So if you have a +2, you also have to have -2, right? So when I look at this, I got +2 and -1. That doesn't work out. So what I have to do is I have to have two -1s. So +2 is equal to -1, -1, or +2 plus -1, -1, or -1 times 2 equals 0, right? So that makes this formula CaCl2. There's 2 chloride ions and 1 calcium ion. In terms of naming them, this is the simplest thing. All you're going to do is you have to figure out the name of the metal ion, the cation, and write that first, and then write the name of the nonmetal ion, the anion. So NaCl is called sodium chloride, and CaCl2 is called calcium chloride. Doesn't matter how many of them there are. It doesn't matter that there's only one Cl here and 2 Cls here. That doesn't matter. You just have to be able to name the two ions. So let's do a couple more examples of this. What I'd advise is you look at this side over here as a place where you can help yourself out. So I'm going to draw on it here. I'm going to look up things. I'm going to look up sodium, Na, and I know that's got a +1 charge. So I'm going to put 1 plus. And then I've got Br, which has a 1 - charge. So those two are a 1-to-1. So my formula for them is going to be pretty simple. It's going to be NaBr. I'm not going to do calcium chloride, but I am going to do aluminum oxide because aluminum oxide is a very, very tricky one. So here we go. I'm going to do this. Aluminum is a 3 positive. If I look at that on the periodic table, I find aluminum right here. So remember, these are +3. Sorry, I skipped ahead, didn't look for Na, which is +1, and Br, which is -1. So aluminum is right here, which means it's a +3. Oxygen is over here, oxide, which means it is -2. Now, those two definitely don't go together. And it doesn't get any better if I add, scroll down a little bit so I have a little more space. doesn't get better if I add another oxygen, right? Because now they still don't match up. I've got -4 and I've got a +3. So sometimes you have to add some to both sides. And what that might look like, okay, so now if I add another aluminum, 3+, now I have 2 3 pluses. 3 plus, 3 plus, I add those together, I get 6+, which means I need to have 6-. I've got 2- and 2-, which means I've got 4-. But if I add another one, I'm going to have 2, 4, 6- to go with 3, 6+. So that's how I can neutralize out. And then when I go to write the formula for this, I am going to write it out Al, and come back here to my subscript 2, come back to normal writing, O3. Okay? So, this is probably one of the most complex ones on there. There might be more like this, so think about that. Most of them are going to be relatively simple, though. It'll be -1 and +2, or +1 and -2, or +1 and -3, for example. You'll have to figure those ones out. This is the most complex one, I will say. Some of them will be easy. They'll be 1-to-1, like sodium and bromide, and you just write NaBr. Some of them will be a little more complex, and you'll have Al2O3. All right, and then finally getting to the naming part. So the naming part, this part I hope is just the absolute easiest for you. I'm going to look at this. K2, the positive ion, the metal ion, the cation always comes first. So K is my positive ion. So I'm going to come back over here, I'm going to find K, and that is potassium. And so remember, when I'm writing it out, I'm going to be like, okay, potassium. And then I'm going to look at my anion, which is O, so that's oxygen. And I need to remember that that is not going to be listed as oxygen, it is oxide, right? So potassium oxide. Again, don't worry about capitalizing the names of the substances. They're not actually proper nouns. They don't need to be capitalized. A lot of people think that, but I'm not going to mark you wrong if you do or anything, but just something to think about. Let's go ahead and remember it's potassium oxide. Even though there's 2 potassiums, it doesn't matter because we know from this, then we can go back and figure it out just like you were doing above. So just like I figured out that, oh, sodium bromide is a +1 and a -1, so those match up, and aluminum is a +3 and oxygen's a -2, and figure that out, that can help you out. If you stick around to the end, I will come back and I will go over the one generally pretty good trick for figuring out the formula. All right, last example down here. Let's do the next one. So Mg, we're going to come over to the periodic table. Where is Mg? There it is. Magnesium. All right, magnesium. And then that is an I, so I'm going to come over here and look for I. I is iodine, so iodide. Magnesium iodide. Super simple. I hope this part is super simple for you. Final thing, I'm going to come down to the bottom here. If you're trying to figure out how to do the formulas, the easiest thing to do is to look at your cation and your anion, right? So say I've got something like, I don't know, let's see. So we'll go magnesium, which is a +2. Come back over here, I go, okay, magnesium +2. And then I've got, say, oxygen, which is a -2. If it's the same number here, you've got the coolest, simplest formula. It's just MgO, right? That's super easy. So that one's pretty easy. But if they have different numbers, you can use those different numbers as well. So say I've got magnesium, which is a 2 plus, and I've got phosphorus, which is a 3 minus. You might have noticed this with aluminum and oxygen above, but here's what I can do. Make sure that's a minus. I can take the number that's by the phosphorus. When I go to make my formula, we can swap these numbers down. So here's what I mean by this. This one's going to come down here. This one's going to come down here. And I'm going to take the positive and negative out because I will need 3 magnesium 2 pluses to match up with 2 phosphorus 3 minuses. That could be my formula right there, Mg3P2. And this works for like anything. So if I have, the one we just did above, magnesium, which is a 2 plus, and iodine, which is a 1 minus, I can drop these numbers down, right? Boom, boom, and I get Mgi2. Remember, I don't need to write the 1 if there's only 1. So this is the super simple way. If you've got different numbers, just drop them and cross them. Put the actual number. When we write the formula, we're not writing the positives and the negatives. Positives and the negatives are only when we're thinking about what the ion is. So that's my super secret hint. Hopefully it helps you out. And yeah, good luck getting this finished up.